They don't have that advantage this time.
Yeah, and we beat them when they were here, so.
I wish we could have beaten who we beat them. Daniel and Josh and Kevin and Mike.
Why would they do?
Not score. Okay, that'll be on the MC and the immortalized on the internet. Okay, anyways, solving quadratic systems. So before we get into this, let's review. Well, linear systems. How do we solve a linear system? Now, linear systems, we have the advantage that we could do them on our built-in Casio calculator solving thing. We aren't going to be able to do that for these. But let's just say we had this. We'll do two of them. And when we did linear systems, we had three ways to do it. We could graph it, we could do substitution method, or we could do elimination method. Now I'm not going to graph these two, but you could do it that way. But I will review with you substitution and elimination method. So substitution method says, I'm going to take the piece, y equals 2x minus 5, and I'll just take that and put it in for y down here. Okay, so that's where this is coming from. 2x minus 5 equals x plus 8. And then I solve this piece using, and this is again substitution method. So I subtract my x, give my x to one side, I'll add the 5, and x equals 13. I'm not done, that's half the answer, so half a box. I take that and I put it back up for one of these. So y equals 13 plus 8, y equals 21.
What did you do with the 2?
Huh?
What did you do with the 2?
I put it in for this one.
No, the 2x minus 5. You subtracted the x.
So 2 minus 1 is 1.
Oh.
And that was my answer, 13 and 21. So my final answer, 13, 21. Okay, so that's substitution method. In the elimination method, I need everything in the form something x plus something y equals something. So I'm going to move the x's over on both of those. So I'll subtract 2x, so I'll have negative 2x plus y equals negative 5. And I'll subtract this x over, negative x plus y equals 8. And then what I try to do is I try to get these to be the same number in front of something, but different in sign. So I see that the easiest to eliminate here will actually be the y. So I'll multiply this second function by negative 1.
All of this stuff, do we have to answer that? Because it says Trig, I don't know where to put it on the answer.
At the bottom, there's the background questions. A, B, C. Yeah, and if you don't have an answer, just make up one. Doesn't matter really. So why am I multiplying by 1? I meant negative 1. So I get negative 2x plus y equals negative 5. You're supposed to be dismissed anyway. I'll bubble in some answers for you.
That's fine. We're not carrying a JV player, so we're leaving.
Later.
Later.
Not
Not like when we're supposed to play. We're gonna go with JV, which is a little later.
And then we add these. We continue solving. And then just like before, I take that 13 and put it back up and get the 21. Is substitution and elimination feeling familiar? Okay. Let's do one more, just to make sure. So let's say I start with 3x minus 2y equals 8. And of course, I'm making this up off the top of my head, so yeah, there's that. Okay, so this is my new linear system. Notice it's in that order from before. So let's use elimination method in this case. All right, so I need the same number in front Choose one. Do we want to eliminate x or y?
Y.
Okay, let's eliminate y. And what would be the common multiple that I would use?
6.
So I'll multiply the first one by 3 and the second one by 2. And then what I do is I add down, and I get 17x equals 24. No, am I dumb? Add those. 48, and then divide by 17.
Okay, I did those, and then the rest is common.
Okay, thank you. Good luck. And now what would we do with 48 over 17? Yeah, you put it back in for x. And I'm not going to bother with that step. I hope you see what you would do. Alright, so that's linear systems. What about quadratic? Well, it's the same thing. You do it the same way. But you might need the quadratic formula, or the factor. So that's going to be a key difference. So let's do one of these. And what we're really hoping is that the x squareds cancel, but they may not. Like in this case, it is not going to be possible to eliminate the x squared. And that's assuming we're going to use elimination. So now you can choose whichever method you want. You can do it both ways. You can do it substitution, you can do it elimination. And in this case, I'm going to choose substitution. Why? Because both of these are already solved for y. Does that make sense? Why I would just choose substitution over elimination method? So I'm going to take all of this and replace it for y down here. Now this is a quadratic thing. And from this chapter, what we've learned to do is get everything to one side, right? So I get a 0. I get negative x squared. That cancels. That cancels. Wow. Whenever I have a negative x squared in this, I'm just going to divide by a negative 1. Or multiply by a negative 1. Doesn't matter. And then I get x is 0. Because I square root that. Square root times do a square. That's half my answer. What do you think you do with that?
What did you do with the negative?
I multiplied both sides by a negative to get rid of it. I can multiply both sides by negative 1. It just so happens 0 times negative 1 is still 0. So I take that 0 and I put it back up. And it doesn't matter which one, really. So my answer is 0, 1. Now, although you can't use the algebraic solver, really, that's built into your calculator to do this, I mean, there is an equation set up that you can do. It's not very good, though. If you want to check this, you would graph it. And you'd say y1 equals negative x squared plus 2x plus 1. And you would put in y2 equals 2x plus 1. And then you would do your g-solve. And you'd look for intersect. Wherever they meet is the answer. And actually, you can use that function whenever you have any equation. You can use that to solve. Use an intersection. All right, let's try another one. And again, I'll just use the substitution method because it's already solved for y in both of these cases. So I'll take all of this stuff and I'll plug it in here. In fact, most of these, actually, substitution ends up being the better option. And just because they typically give it to you as y. And get everything to one side. So in the end, they basically are just like everything else you've been doing this chapter. I think I might have made a boo-boo.
What?
Yeah, I did. I'm stupid. Alright. This should be negative x plus 2 is plus x. And I can't add for some reason. Ah! There. That's correct. Negative 1 plus 2 is 1. Alright, this actually turns out to be factorable. Now, if it isn't factorable, that's okay. Use the quadratic formula. And now I'm going to get two answers, right? X could be negative 2 or x could be 1.
So what do we do about that then?
Well, now we put them in one at a time.
Test it.
Well, we put in this negative 2. Now, again, it's not going to matter which one of these I put it in, so I'm going to choose this linear one, this bottom one, just because it's easier, no squares or anything. So it would be y equals negative 2 times negative 2 plus 5. That's a 2. So we get 4 plus 5, which is 9. Okay, so y equals 9 for that one. Now I'm going to do x equals 1. So y equals negative 2 times 1 plus 5, which is negative 2 plus 5, which is 3. Alright, so y equals 3 is the other answer. So I have two answers, negative 2, 1, and, negative 2, 9, sorry, negative 2, 9, and 1, 3. Two answers. If I graph this, which I would like you to go ahead and on your calculator, in y1, put in x squared minus x plus 3. And in y2, go ahead and put in negative 2x plus 5. Make sure you have your standard view window. And see where they do your g-solve and intersect. And since that's in your notes, I'm just going to go ahead and go on to the next one while you're getting that all set.
What are we doing?
You're putting this into y1 and this into y2 in your graph mode. And then you g-solve and find out where they intersect. I think it's, I don't know how they abbreviate it.
Negative 2 and 9. They have two intersections of 1 and 3.
And that's what we have. Okay,
So-
and you use your arrow keys to cycle between the two answers.
So in other words, for these ones, it's not going to be necessarily one or the other, but rather both intersections.
Yep, it's both of them. Wherever it intersects, that's the answer.
I think you get two answers.
Let me see your calculator. Did you graph it? Oh, here it is. So y1, y2, and intersect. Okay.
The Y's.
Here, let me see.
No, I mean, like, what were you doing?
Yeah, we're just testing it. So G-solve, intersect.
Yeah, I know how to do that, but How did you get y equals 9 and y equals 3? By putting in both.
Yeah, we took this negative, I took this -2, and I put it back into one of these. I did it up here. -2, I put it into here, and got y, and I did the 1, I put it in here, and got the 3.
How do
I
we
did-
do log?
LOG.
No, like, how do you solve?
You haven't done it yet. I don't think. Let me see. Yeah, we haven't done that yet, which is okay.
So just
Take-
guess?
Yep, take a guess. That's actually coming up in 2 chapters. Alright, wait, where is, I thought I wrote down, what in the world? Oh, there it is, okay. So here's another, and really it's just rinse and repeat. Do the same thing over and over and over again.
What?
Rinse and repeat, as in each question is basically the same. We take all of this stuff right here, we put it in for y, doing substitution. X squared plus 4x plus 1. I mean, when it's already solved for y, substitution is going to make sense as the best option. Get everything to one side.
Is this for you?
This is just another example of what we did. So if you just prefer not to write it down, like it's going to be another example of what we just did. Now I tried to solve this. If it's a quadratic, I need to factor. So I go ahead and factor. The common thing to factor out is an x.
X equals 0 or x equals -3?
Yep, so x equals 0. Or x plus 3 equals 0, which means x equals -3. Now I take both of these, and one at a time I come back up. So I take this 0, it doesn't matter which one I put it in, I'll get the same thing. I'll just choose the easier one, which is this one. And y is 1. So I put that with that x, I'll do this -3. So I put it in for x right here. So y equals -3 plus 1, which is -2. So y is -2 for that one. So my two answers are -3, -2 from right here, and my other answer is 0, 1. And again, you can check that using your graphing calculator. Let's do a trickier pair now. Let's try this system. And no matter how complicated that is, I'm going to take all of this stuff. Boop. And now, what I've been wanting to happen actually happens. I said earlier, what we would really love is for the x squareds to cancel. And this time it will. I get everything to one side. So I subtract all of this stuff over. And on the right, I'll have a 0. On the left, notice the x squareds cancel and I get 3x equals 0. So I divide by 3 and x equals 0. And like before, I take that and I put it back into one of these. I'll just choose the bottom one. So that's going to be y equals 0 squared plus 2 times 0 plus 1, which is 1. So what's my answer? 0, 1. Now, sometimes we're not so lucky. Should we do another one where we're lucky? No? Good. Because I didn't want to. Let's do one where we're unlucky. Let's get an unlucky one. The process is still the same. It's just a matter of, is baby luck on our side? Yeah, baby luck. Yeah, baby luck and the fat lady.
Who's the fat lady?
When she sings, you're done.
Oh, baby. Is that what it's supposed to be? Baby.
And I think the baby belongs to the fat lady. Alright, so we do substitution. Now we could do elimination. If we did elimination for all of these, we would eliminate y. We would not try to eliminate x because there's too many of them. So we would have trouble, right? So we'd eliminate y. So substitution definitely, again, is the better option. Okay, and then we get everything to one side. In this case, I'm going to get everything to the right-hand side, just so that I have positives on my x term. Okay, so I'm just getting all of that stuff to the right-hand side. So on the left, I have 0. Now I have 4x squared plus 3x minus 1. And now I am the unluckiest person possible. This is horrible. Now it is factorable. I could factor this. And when we start to factor it, and I don't want you to write this down, I want you to pay attention to how we go through this factoring. I usually start my factoring like this, right? Now luckily I only have 2 options here. Now one of these is going to have to be negative and one positive. And I see that my check won't work. I'll get negative 2x and 2x, which is 0. So that does not yield the 3 that I need. Alright, so right away I find out that 2x and 2x is not going to work. So now I move down the line to 4x and x. And again, I only have 2 options for this. So 1 and 1, of course, but then negative and positive. And I might say, well, negative here, positive here. And then I do my check. This is x. This is negative 4x. And when I check, I get negative 3x. That does not compute. That's not right. So we change our signs right here. And then when I do my check, I get negative x and 4x, which does give me the 3x. So this is the correct factoring, which means 4x minus 1 equals 0, and x plus 1 equals 0 from before. We solve both of these. X is a fourth, and x is negative 1. But now I'm going to have to go back to my equations here and get y. Right? I'll do this 1/4. I'm going to use this second equation because there's not that negative 3. So y equals 1/4 squared, plus 2 times a fourth, plus 1. So we get 1 over 16, plus this will be a half, and plus a 1. And in order to add those, what do I need? Common denominator, right? And my common denominator is 16. We put in the negative 1, and I'll also do that. Y equals negative 1 squared plus 2 times negative 1 plus 1. Negative 1 squared is positive. And we get a 0 right there. So what's our answers? Negative 1, 0, and 1/4, comma 25/16. And again, we can use our calculator in order to graph these to solve them. In fact, the first 3 questions of your homework say specifically, do it on a calculator. So use your G-solve and practice getting it on your calculator. It says check your answers. Well, by nature of doing it on the calculator, you have done that. Alright, good luck. Just write it in. Alright, should we do another unlucky one? Yes, let's do another unlucky one. Although this one comes out, so it just looks like it'll be unlucky.
Why are we doing it again?
Huh? In this case, I am going to use substitution. Yeah, I'm going to solve for y first. Okay, so I'll add that 2x, and I get 3x plus 5. And I'll subtract that 1, and I get x squared plus 5x plus 2. Now I take this stuff, boop, get everything to one side, and this does factor, plus 3 and minus 1. So x equals negative 3 and x equals 1. And then one at a time, I put them back up. Now I'm going to go ahead and use this right here. So my y will be negative 9 plus 5, which is negative 4, I believe. And right here, I put in the 1, which is going to give me 8. So my answers are 1, 8, and negative 3, negative 4. Let's go ahead and again use our calculator to check that. And I would make sure your view window, always to start out, is standard. Or y min is negative 10, y max is 10, x min negative 10, y max 10. And now, of course, if I had answers that were outside of this, I would increase or decrease those accordingly. Well, you solve for y.
Solve for y, yeah. You solve for y, you put that in.
Yeah, I can't put these in because there's stuff over here with this y. So I would have to put in this stuff right here in order to graph those. So y1, I'm going to put in 3x plus 5. Well, where did I get that? I added this 2x. And then y2, I subtract that 1. So I put this one in. So I put x squared plus 5x plus 2. And then I g-solve it. Graph it and g-solve it. Alright, one more. I know how much fun these are for you. And then we are pressed for time, but we do have one more type that we need to do. Alright, so I'm going to solve for y. This one is looking really mean, this first one. But baby luck's on our side. We subtract the y. Y, because I need the y's all on one side, so I get y, and I have negative x squared plus 1. And the second equation is 5. So I'll take all of that and put it in here for y. Don't drop your negative. Now I'll get everything to one side, so I will add x squared and subtract 1. And I get 0. Then over here I'll get 2x squared minus 5x minus 3. This does factor, but if it doesn't, that's okay. I can use the quadratic formula. I see a 5 here, which gives me a hint that I should probably have a 3 over here on the right to get a 6, and then a 1, probably a plus here and a minus here, because when I go to check, 2 times negative 3, negative 6x, 1 plus x, that's x, so that gives me negative 5x, which is what I need. So my two answers then, 2x plus 1 equals 0, or x minus 3 equals 0. And I solve both of those and I get x equals negative a half, or x equals 3. And then I put those back in one at a time. I'm going to use this this second equation right here. So y equals negative 1/2 squared minus 5 times negative a half minus 2. And I know that's crunched up there, but that is negative half. Negative half squared is a fourth. And then I multiply those, so that's plus 5 halves. And then I have minus 2. And again, in order to add fractions, I need a common denominator. So that's going to be a 4. So I combine all those, 11 minus 8, 3/4. Yep. So my first answer is negative a half and 3/4. And I'll erase that piece right there. Let's do the 3. So y equals 3 squared. Notice I do put that in parentheses to make sure in case I square a negative that it gets to be positive. And we get negative 8, so 3, negative 8 is the other answer. All right? Okay, now, to do the last thing, which hopefully I don't run out of time for, but I think I probably will. But I do want to finish that. Would like to finish this section up just to talk about it. The next thing actually is the same section, but what we need to do is graph an inequality. They just lumped it together here with the equalities. Now you can't solve it in the same way, but basically it's just graphing work, which is why we've graphed enough of these at this point that we should be able to do this. So let's say that I need to solve y is less than, so now it's not an equal to, 3x squared plus 2x plus 1, and y is greater than or equal to 2x squared minus x plus 1. And that's my system. So I'm not going to do what I've been doing. I'm going to attempt to graph that. Well, to graph it, I need my vertex form for both of them, right? And my vertex form is y equals a x minus h squared plus k. So I'm going to get that first one. And do you remember, how do I get h? H equals what? Negative b over 2a. So for the first one, I'm going to have negative 2 over 2 times 3. So h is, negative 1/3. Really? Did they do that to me? They did that to me. Oh boy. Alright, so we take that negative 1/3 and we put it into here to get k. So let's get our k. Did I do that? Let me just double check. Did we do that right? Negative b, negative 2 over, yep. Unfortunately, we did that right. So k is going to be 3 times negative 1/3 squared plus 2 times negative 1/3 plus 1. I gave you the big kahuna, so I do this. So that's not 1/9. And 1/9 times 3 is 1/3. So there's 1/3 minus 2/3 plus 1. Okay, well they threw us a bone here a little bit. K equals negative 1/3 plus 1. So that's going to be 3 over 3. So K is 2/3. Alright, so our first equation is y equals, now A is 3 because that's in front, 3 x plus 1/3 squared plus 2/3. Alright, I'm going to erase all this. I hope that second one comes out a little bit nicer, but I have a feeling it won't. Okay, so this one, again, h is negative b. So that's going to be 1 over 2a. So that's going to be a fourth. So I put that in, and k is 2 times a fourth squared minus a fourth plus 1. So that's going to be 2 times the 16th, because square those. And that's going to cancel down to an 8. So now I need a common denominator. It's going to be an 8. So I have 1/8 minus 2/8 plus 8/8. In short, I'm adding these. Okay, I got my h by negative b over 2a.
I got that, but the 1/8.
Okay, so now I square the 1/4 to get 1/16. I multiply, so those cancel. So that's where my 1/8 comes from. But in order to add these fractions, I have to have a common denominator. So times 2 times 2. And the 8/8, well, that's a 1 over 1, so times 8 over 8. So now, I can't just add these without a common denominator. So I got my common denominator. And 9 minus 2 is 7/8. So my second equation is y equals 2x, oh gosh, how in the world are we going to graph this?
That's 7/8.
Minus 1, yep, it's 7/8. Minus a fourth squared plus 7/8. Oh boy, of course I would choose the hardest one that the book gives. So we will graph these. This is going to be a solid line, right? And this is going to be a dotted line. I think we'll practice ones that are easier on Monday. So I'll have to come up with them. I'll have to think. But anyways, this one we start at negative 1/3, 2/3. So negative 1/3, 2/3 is like right there. Right? And my stretch factor is 3. So if I go right 1, 1 squared is 1, times 3, up 3. So 1, 2, 3. And yeah, it doesn't land exact, does it? And if I go left 1, it should be the same. So it's very, very narrow. And this should be a dotted line. I'm not going to do another one just because the bell rang in time. Now, this is less than. So I should shade below this line. Does that make sense? Below? So I would shade lightly with my pencil all this way. Alright, let's graph the next one. We start at a fourth and 7/8. So that's going to be really hard, but it's like right here. I don't even know if this will let me be that precise. Okay, but it's like right there. And if I go right 1, 1 squared is 1, but times 2, so up 2. So 1, 2. I'll do one more. If I go right 2, 2 squared is 4. 4 times 2 is 8, so I'm going to be way up here. So this is going to be a solid line. Let me get the other one. The other one will be right here. So this is going to be very, very, like, weird. This will be solid. Alright, and then I shade above that one. So if I shade above that one, now I know it's going to be, it would be very hard to see, but this other one, the red would be in there, and then in blue, above that one, oops, in blue, because I said blue, above that one. Hopefully you see though, I'm actually going to erase all that because it's going to be too sloppy, but the answer is the overlap, which is right here, this sliver, is the final answer between those two. Because we shaded below this dotted one and above this solid one. So they overlap right here in this sliver. Okay? So we'll work more on that next week, and that's it.